In today's lesson, we're going to be looking at some extra practice as well as angles of elevation and depression. So for this page here, you're going to be completing these 3 examples. I have the final answers written here. So once you have tried these questions out, come back here and check your work just to see if you did it correctly. And if not, make sure that you let me know when you ask. But I'm just going to leave this extra practice with you, and we're going to move to the 3rd lesson on applying trig ratios to angles of elevation and depression. So let's first take a look at angles of elevation. The angle of elevation is the angle between the horizontal and the line of sight up to an object. It's also called the angle of inclination. So let's say, for example, you are walking. This is you. And you see a bird in the sky. And that is a bird in the sky. And you look up at that bird. If you look up at that bird, this is your line of sight, right? And your things that are at eye level are here to you, right? And then you actually notice that we see a right triangle there. And so the angle of elevation is the angle between the horizontal and the line of sight up to an object. So in this case, this is your angle of elevation, and I'm going to write as AOE. Okay. Let's take a look at an example that has some numbers in it. So Benson is playing his rock harmonica before an adoring crowd. From a height of 1.7 meters, his sight line forms an angle of elevation of 43 degrees to the nearest spotlight. If the distance directly from his eye to the spotlight is 12.3 meters, how high is the spotlight above the ground? Okay, so let's draw Benson. This is Benson. Looks very much like you. And there's a spotlight here. Okay. And so it says that from a height of 1.7 meters. So that means that Benson here is 1.7 meters tall. And his sightline forms an angle of elevation of 43%. So remember, the angle of elevation is from our horizontal line, and a horizontal line is what's at eye level. And we see here that we have a right triangle. And we're told that this angle here is 43%. And the distance directly from his eye to the spotlight, so from his eye to the spotlight, is 12.3 meters. We're asked, how high is the spotlight above the ground? Okay, what we're trying to find is this, right? Because this is the ground. We're trying to find how high the spotlight is from the ground. Well, we already know this distance, right? We know that Benson is 1.7 meters. We just need to find this distance and then add these two together. What that means is we have to find the height of this triangle. So in order to find the height of the triangle, we're given an angle and we're given this side here. And we can use a certain trig ratio to help us find x. But let's label our sides so we know which trig ratio to use. So we're given the angle 43 degrees. We always know that the angle across from the right angle is our hypotenuse. So this is the hypotenuse, h. And x is the side opposite to the angle, so this is O. I'll change it from x to O. There. Okay, so if we're given our opposite and we're given our hypotenuse, we're going to then use sine, because sine is opposite over hypotenuse. So sine of 43 degrees is equal to opposite over hypotenuse. And we know that our hypotenuse is 12.3. So in order to find the opposite side, we're going to multiply both sides by 12.3. And we get that O equals 12.3 times sine of 43. And we will get 8.39. So that means that we know this distance now. We also know this distance. So in order to find the total distance above the ground, so distance above the ground is what we just found, 8.39, plus how tall Benson is, 1.7. And that will give us 10.09 meters. And that's how high the spotlight is. Let's take a look at angle of depression. So angle of depression is the angle between the horizontal line and the line of sight down to an object, also called the angle of declination. So again, let's say we're a bird now, okay? We're a bird up here. And we're flying in the sky and we see a little itty bitty human being there. Oops, I'm trying to draw the ground. Okay. So if we were up the bird and we were looking down at this person, this would be our line of sight, right? We would look down. And it again is between the horizontal and line of sight. So horizontal is the line from the person and across. So again, it's at eye level to the person. We see here that we have another right triangle, and this here is our angle of depression. So I'll use AOD. And you'll actually notice that it's pretty much the same as our angle of elevation, because both of them are the angle between the horizontal line and the line either going down or up. But it just so happens that the angle is at the same spot. Okay, let's take a look at an example. Sarah is on horseback riding towards a stable when her horse stops to graze. From a height of 2.6 meters, Sarah's sightline makes an angle of depression of 6 degrees to the threshold of the stable. How far are they from the stable? Okay, so let's see. Sarah's on a horse. I'm not even going to attempt to draw a horse. I'm just going to go right into the triangle. So Sarah's up here, and she's 2.6 meters up, and her sight line makes an angle of depression of 6%. 6% is actually going to be quite small. I'm going to make our triangle a little bigger. So makes an angle of 6% to the threshold of the stable. So, oops, sorry. I shouldn't have drawn it like that. I should draw it like this. That's much better. Because, remember, angle of depression is from the horizontal line down, so it's in between these two. So this is 6%. And we're asked, so this is the stable. I'll kind of just draw a little stable here. Okay. And we're asked, how far are they from the stable? So what that means is we're trying to find this length. Okay. So again, we're given an angle, we're given a side, and we're trying to find a second side. So we're going to use a trig ratio, and let's determine which trig ratio to use. So recall that the hypotenuse is always the side opposite to our right angle. So in this case, this is h, which we don't have and we don't need. Okay. If we are looking at, if we're using 6% as our anchor angle, 2.6 is our opposite. And the side that we're looking for is our adjacent. So I'm just going to relabel it as A. So if we're given our opposite, trying to find our adjacent, which trig ratio do you think uses O and A? Pause for a moment to think. So we're going to need to use tan, because tan is opposite over adjacent. So we're looking at tan of 6% is equal to opposite, which is 2.6, over adjacent. Okay? So we can turn this tan into a fraction, and we can cross multiply. So we can cross multiply like so, and we'll get, so tan 6 times A is A times tan of 6 degrees is equal to 2.6. And then let's divide both sides by tan of 6 degrees. We get A is equal to 24.74 meters away. And that's how far Sarah is from the stable. All right, let's do some practice. So on this next page, you're going to do all of the questions. You're going to have to draw some triangles and find the lengths of the sides, practice with angles of depression and elevation. And once you're done, make sure that you check your answers.